Hello and welcome to a Rygame Maths video. In this video we're going to be looking at the critical path analysis topic from the first year Decision 1 Mathematics unit from the Further Maths specification. My name's Simon, and in this video we're going to be focusing finally on critical paths and something called floats. Let's start with some definitions. A critical activity is an activity for which any increase in its duration will result in an extension to the overall completion time of a project. So it's critical because if you delay it at all, the project will be delayed. A critical path, which is in the name of this topic, is a path from source to sink that is made up of critical activities. Now, something that you have to consider are critical events, which are events in which the early and late times are the same. All critical activities will be made up of critical events here and here. So every critical activity will have that property. But not all activities joined by critical events are critical, so you need to be careful with that. So not all activities joining critical events are critical activities. So just looking at your activity network, just looking at the events is not enough to identify a critical activity. You actually need to think about it. Let's start by looking at an example and labeling the critical activities. So we've got an activity network for a project here. This is the example we're going to use to look at critical activities and critical paths. To recap the previous video, please stop the video now, have a go filling in this activity network using a forward and backward pass, then unpause the video and we'll talk about critical paths. So this is what you should have got. So let's have a look at which activities are going to cause a delay in the project. We can very quickly see the ones that aren't, because this event here, this one that joins sort of C, E, and F, this is not a critical event. So we already know that these three activities, C, E, and F, are not critical activities. In fact, because this is a relatively small network, all of the other activities are critical. We can see that here, with G, if G goes from 2 to 3, that will change this finish time to 17, not 16, because 11 plus 5 is 16, 14 plus 3 is 17, that we put the biggest one going forward, and then that'll have an effect. Same thing with D, H, B, and A. So the critical activities are A, B, D, G, and H. We can see that there is a clear path from source to sink that uses A, B, D, and G. But there is another critical path that goes A, B, uses this dummy, and then H. So you can have multiple critical paths. There is not a single, or there's not necessarily a single critical path in any project. You might have multiple critical paths. That can be useful in sort of the scope of project management, because you know that everything is important. You know that any delay in any of these paths is going to cause a delay to the project. and will give you some wiggle room with the other part. But it's also bad because it means you have very little flexibility in your project, full stop. So that's how you identify critical paths. But let's quantify the idea of wiggle room. Float is the measure of this wiggle room. The float is the amount of time, or the unit of whatever it is you're talking about, the amount of time which an activity can be delayed without it having an effect on the completion time of the project. The float of an activity is calculated by the latest finish time, so the bottom box at the end, minus the duration, minus the earliest start. So the top box at the start. So it's this one, minus this one, minus this one. So if we can see, we can have a look at A. We can see the float of A is going to be 4 minus 0, which is 0. This is true of all critical activities, that the float of a critical activity will be 0. The float is really important for when we start looking at the next section, which is called Gantt charts, as we'll be able to display the float on those diagrams. Let's very quickly calculate the float for each of the remaining E, F, G, H activities, and we'll see that property of the critical activities having a float of 0. So be 11 minus 7 minus 4 is 0. C, so we've got the latest finish time minus the duration minus the earliest start time, which gives us a float of 3. So this means that C can be delayed by up to 3 days, and that won't affect the completion time of the project. If C is delayed any further, then that will change the completion time of the project and will actually likely change the critical activities and the critical paths. D, 14 minus 3 minus 11 is 0. E, 11 minus 1 minus 7 is 3. So because there aren't many non-critical activities, you'll see the floats, the numbers of the floats will come up quite often, and they are linked together. Don't count on that, but that is something that you can spot. So F, we're going to have 16 minus 4 minus 7. We can see that here. 7 plus 4 is 11, so F has a float of 5. So although these two have the same float, just because F is non-critical doesn't mean it's going to have the same float. 16 minus 2 minus 14 and 16 minus 5 minus 11 are both also 0. So again, we can see that the critical activities all have a float of 0. So this is usually the quickest way to spot whether an activity is critical or not, is to look at its float. Something to bear in mind with critical activities and critical paths, as we've said, there could be multiple critical paths for a project. You may also have critical activities that are not on a critical path. It's unlikely but not impossible, so don't panic if that happens, but it might be something that you want to double check you're working for. That's everything to do with floats, critical paths, and critical activities. The next topic, the next video, is going to cover Gantt charts, which is the final part of this topic. Thank you for watching.